Hey guys, I want to make a quick video just demoing a few problems that might be tricky. I'm going to start with number 2. I think I did a little bit of number 2, but I figured why not do the whole thing with you guys. So for number 2 here, these are not the same function. So I want to try to put these into the same function because then I can do things like I did on number 1 and like I do on number 4 and factor. So if I look at cosine squared x is the same as rewriting this 1 minus sine squared theta. I can rewrite this, so I can rewrite this as cosine squared theta equals 1 minus sine squared theta, and that's what I want to substitute in. I want to substitute this identity. So let's go ahead and substitute that in. This whole thing becomes 1 minus sine squared x. And now I'm in the same function. Everything is a sine. So I'm going to look to factor. But first, let's see what we can combine. Here I have 1 minus 1. That creates 0. So I just have negative sine squared x plus sine x. I want to actually think of this as if this whole thing right here was just a variable. Let's call it a. And this is that same variable here. Let's call it a. Now, if I were solving this, I would notice since I have two a's here, I can factor out an a. It's like dividing each term by a, so this becomes negative a plus 1. And now I can set each individually equal to 0. A equals 0, negative a plus 1 equals 0, or a equals 1. So now I have to remember this wasn't actually a, this was sine x. So sine x equals 0 and sine x equals 1. So where does sine x equal 0? If I'm thinking through my unit circle, and you guys can totally reference your unit circle in this process, as the y coordinate, here and here are where my sine equals 0. Because if you notice, this is 1, 0, negative 1, 0. So for this one, the solution should be x equals 0, that's this angle right here, and pi, that's this angle right here. So now when does sine equal 1? Well, right here at the top of our unit circle, that's 0, 1, and since sine is our y coordinate, right there at the top of our unit circle at pi over 2, we have sine equals 1. Again, this is pi over 2. So there are all of our solutions. If I want to write them together, that just simplifies it. So here I have 0, pi, and pi over 2. So this is an example where I want to get everything in just one term or one type of trig function. So I changed my cosine squared to a sine squared using my Pythagorean identity. Okay, let's try another one. Here is one where we don't actually really need any identity. So let's solve for this. I'm going to solve for this just by getting the secant by itself. So that means I'm adding 2 to both sides. Secant squared x now equals 2. And I still want secant by itself. So that's where I want to remember that this is actually secant squared. So I'm just going to rewrite that because then it's kind of clear to see what can we do. We can take the square root of both sides. So now secant x equals radical 2. But I have to remind myself that secant is not my most familiar function. I'm way more familiar with its reciprocal function. Its reciprocal function is right here. Secant theta equals 1 over cosine theta. So I'm going to go ahead and replace that. 1 over cosine x equals radical 2. But it doesn't help me having cosine in the denominator, so I'm just going to take the reciprocal of both sides, which means that I can flip the fraction upside down on both sides. So now I have cosine x equals 1 over radical 2. And if we rationalize that, radical 2 over radical 2, we find out that this is actually square root of 2 over 2. And now I can go back to my unit circle and say, well, where is the cosine radical 2 over 2? Where is the cosine radical 2 over 2? Well, that pi over 4 angle right here has a cosine of radical 2 over 2. So where will I have the same cosine? Well, let's think about an x value exactly the same. Should be down in this quadrant right here. So if this angle is pi over 4, this angle is just pi over 4 short of 2 pi. If I think of 2 pi as 8 pi over 4, it's just one shy, so that's 7 pi over 4. So we have two answers here. X equals pi over 4, that's in the first quadrant, and 7 pi over 4. That's in the second quadrant. But let's go back to a step that I missed. When I took the square root right here, I did not just get the positive value. I got both the positive and the negative. And that positive and negative carries throughout. So I'm not just looking for the positive value. And I showed this separately because I know this is the biggest mistake I see over and over and over. When we take the square root, it's both positive and negative, and all I gave you are the positive values. So don't forget that we also need the negatives. So that means I do need this 3 pi over 4 and this 5 pi over 4. So all of the pi over 4 angles will work this time. So I like to write them in order just so I see that I don't miss them. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. There are all the solutions to that problem right there. Okay, one last one to try. Here I have a cosine and a cosine, but one of them is 2x and one of them is just x. Sadly, I cannot combine those. Those are not like terms. But I think this is one of those new formulas we learned. So let's go back to the page before and let's see if we can substitute something else in. So on the page before, our double angle formulas, we have 3 of them to choose from. So knowing that I have a cosine x, I want to choose the one right here that has cosine also. So I'm going to substitute 2 cosine squared u minus 1. I'm going to substitute that in. So this is now being replaced with 2 cosine squared x minus 1 plus cosine x plus 1 equals 0. So again, we have negative 1 and positive 1. Those add 1 minus 1, that becomes 0. And I have 2 cosine squared x plus cosine x equals 0. So let's think about this again. It's just a variable. Cosine x, let's say it's just the variable a. So this is like saying 2a squared. Cosine x is the variable a plus a. Well, I have an a in each term. Let's factor it out. It's like dividing by a, so this becomes 2a plus 1. And we can set each one individually equal to 0. A equals 0, or 2a plus 1 equals 0, or a equals negative 1/2. But that's when I remember that a is actually cosine. Cosine of x equals 0, and cosine of x equals negative 1/2. So let's think through our unit circle one last time. This is 1, 0. This is 0, 1. Negative 1, 0. 0, negative 1. Where is my cosine equal to 0? My cosine is equal to 0 right here and right here. So that's the angle pi over 2 and 3 pi over 2. And where's my cosine equal to negative 1/2? Our cosine is equal to negative 1/2 right here at 2 pi over 3. And then again, directly below it, because it's the same x value, right there at 4 pi over 3. So here we have our 2 pi over 3. It's our negative 1/2 and our 4 pi over 3. So just adding those solutions on, 2 pi over 3 and 4 pi over 3. So there is another example for you guys. Hopefully that helps out. Please bring any of your questions